the DFT. So before going for the properties of the DFT, so what we'll do is, before going for the properties for the DFT, we are going to consider the one of the important property we'll consider, that is the concept of the circular shift and symmetry. So since we are going to consider the x of n is a periodic sequence, since we assume x of n is the periodic sequence with the period equal to the capital N. So whatever the periodic sequence x of n and x of k we consider, so here we need to think about the whatever the shift you are going to do and whatever the reflection we are going to take here. For example, assume that the sequence x of n is equal to the, so it is 1, 2, 3, 4. And if I want to shift the sequence towards the right side by some 2 units, we are going to call this one as a circular shift you are going to call. Why? Because it's a periodic sequence. So whatever the shift you are going to call it as a circular shift, and not indicate that one as, we are going to call that as a modulo n we are going to call. So this n refers to the periodicity. So in case of this one, the value of n is equal to 4. So whatever the shift you are going to perform, that is x of n minus 2. So this is called as the modulo 4 we are going to consider. So whatever the sequence when you're going to shift one time here, so it has become x of n minus 2. When we shift first time, it has become x of n minus 1, the mod 4. So here what happens here, the periodicity is equal to 4 here. The periodicity of the sequence is equal to 4, that is 1, 2, 3, 4. When I shift the sequence towards the right side, it has become 1 here, 2, 3, and 4 will get here. So whatever the 4 that is going out, that is going to 4 and will come and occupy the first position. So the sequence will become equal to like this here. So this is x of n minus 1, we can call it as x of 4, 1, 2, 3. So this kind of shift we are going to call it as the circular shift we are going to call. So it is called as the circular shift you are going to call. So since we are shifting the sequence towards the right side for the periodic sequence, that's why it is called a circular shift here. So similarly for the x of n minus 2, so n minus 2 modulo 4. So again, shift the sequence towards the right side by 1 unit. When you shift here, 3 will go out, the 3 will come and occupy the first position. So it is 3, 4, 1, 2. So we got this sequence. This is called as the circular shift of the sequence we'll call here, circular shift. Similarly, this is why we get it called circular shift, because it's a periodic sequence. That's why you're going to call it a circular shift here. So similarly, if you want to shift the sequence towards the left side, so it is, for example, assume that x of n plus 1 mod 4. So what happens here, x of n is 1 here, so that 1 will go out, that 1 will come and occupy the last position here. So when we shift towards the left side, so 1 will go and that 1 will occupy the last position. That is for the left shift operation. So similarly, x of n plus 2 mod 4. So this has become the 2 will go out, it will come and occupy the last position here. So when you shift towards the left side, the 2 will come and occupy the last position here. So that is this 2 will come and occupy the last position like this. This kind of shift you are going to call it as the circular shift we'll call. Similarly, we'll take the concept of the reflection. So reflection is nothing but, so usually for the sequence, for example, x of minus n. So we know the sequence x of n is 1, 2, 3, 4. When I take the reflection, it has become, so 4, 3, 2, 1 will happen here. So the time index for this one is n is equal to 0, minus 1, minus 2, minus 3. This is for the normal sequence. But since we are considering it's a periodic sequence, so here we need to consider as a circular reflection we need to consider, and that one we are going to denote as a modulo n we are going to denote. Modulo n. The value of x of minus n can be mathematically can be written as x of n minus n we can write here. So since it's a reflection, we need to take in the circular fashion. So how we can take is, so we can take like this. I'm going to represent on the circle. With the circle is having the 4 values. This is the time index n is equal to 0, 1, 2, and the 3. So when you go in the clockwise direction, it is a positive values. When you go in the anti-clockwise direction, so this sequence will be equal to 0, and this will be equal to the I'm going to indicate the anti-clockwise with the red color. So this is minus 1 when you go in the anti-clockwise. This is minus 2, and this is minus 3. So for the clockwise direction, we are going to denote as the sequence as x of n. For the anti-clockwise direction, we are going to denote as a x of minus n mod n, we are going to call x of minus n mod n. So now when I want to find out the x of minus n for this one, so I need to take in the anti-clockwise direction I need to take here. So for example, the values I'm going to denote as, so these are the values 1, 2, 3, 4. When I take in the anti-clockwise direction, so x of minus n mod n can be written as, so since the value of n is equal to 4, we can write that as, so it is 1, 4, 3, 2 will get here. This is kind of reflection we are going to call it as the circular reflection we'll call here. So these properties are, these concepts are very important in order to take the properties of the DFT. So it will be useful when you are applying the properties of the DFT. So we have seen the concept of circular reflection as well as a circular shift we are seeing. So with these fundamentals, we'll go for the properties of the DFT. So before going for the properties, let us recall the formulas for the DFT. So I'm going to write the formula for the DFT as DFT of x of n. So x of n is the input, the corresponding output is x of k. So this concept is very important. So summation n is equal to 0 to n minus 1. Since x of n is the input, we are going to get x of n here, and it is omega into the power of k into n. So here k can take the value from 0 to n minus 1. So similarly, the IDFT of x of k, so the IDFT of x of k is nothing but x of n. So it is, since x of k is the input, so it is the function is the summation of k. Summation is a function of k. It is x of k into omega n to the power of minus k into n. 0 is less than n is less than or equal to the k minus 1. So with these basic formulas, we are going to evaluate the properties of the DFT, and we'll consider the first property of the DFT, which is called as the linearity property. We'll see that one. It is common among all the DFTs, all the transforms. The linearity property is common. So let us look into this property, linearity property, that is called the linearity property of DFT. So we'll consider that one. The linearity property of the DFT will consider. So what it says is, if the DFT of the statement of the property is like this, if the DFT of x of n is equal to, if the DFT of x of n is equal to x of k, then what we have is a into x1 of n plus b into x2 of n. So if you take the DFT, so this will be called as a into x1 of k plus b into x2 of k. We are going to consider that one. We are going to call that as a b into x2 of k. We are going to consider. Now let us consider the LHS part. We are going to evaluate this one. Let us call this as equal to something called the x of n. So we'll consider write the formula for the x of n. So we'll consider the proof. The x of k is nothing but summation n is equal to 0 to the n minus 1 x of n into omega into the power of kn. So in place of x of n, I'm going to substitute this a into x1 of n, and this one. It is a1 into x1 of n plus a1 into x1 of plus b into, this is a only, not a1, b into x2 of n into omega into the power of kn. So let us expand the summation. So it has become x of k is equal to, so a1 is a constant, we'll take outside the summation 0 to n minus 1. So x1 of n into omega n to the power of kn plus a2 into summation n is equal to 0 to n minus 1 x2 of n. So this is a b actually, and this is a, not a1. So x2 of n into omega n to the power of kn. So since this is the DFT formula, and x1 and x of n is the input here, so we can write x of k as the a into x1 of k plus b into x2 of k. So this is the linearity property. So this is the sum of the individual sequence if you are going to give. We can find out the DFTs individually, and we can evaluate the DFT of the corresponding terms.